Greetings of the day. I'm Dr. K. Raghuram Mohan Reddy. The course name is Unconventional Machining Process. Today's topic is electro-discharge machining, flushing and applications. I am Dr. K. Raghuram Mohan Reddy, Department of Mechanical Engineering, Associate Professor. At the end of this session, student will be able to first one, understand the various methods of flushing in electro-discharge machining. Second one, understand the applications of electro-discharge machining. Okay, these two are the course learning outcomes of this today's topic. Okay, right. So in usual manner, let us discuss the various categories of non-traditional machining processes. Okay, the first one is mechanical, second one thermal, third one chemical and electrochemical. Under mechanical, ultrasonic machining, water jet machining, abrasive water jet machining, ice jet machining. Under chemical and electrochemical, chemical milling, plasma chemical milling, electrochemical milling. Under thermal, electro-discharge machining, electron beam machining, laser beam machining, ion beam machining, plasma beam machining. Now, the today's topic is electro-discharge machining. Under this, we are discussing the flushing topic. Okay, so already we have discussed that between the tool and the workpiece, the dielectric fluid medium will have to circulate. So regarding that dielectric fluid medium, it will have to have some properties including the flushing. Okay, we'll discuss all those things in detail. Okay, right. Flushing of EDM. Flushing of the dielectric plays a major role in the maintenance of stable machining and the achievement of close tolerance and high surface quality. Okay, here the 2 points. One is high surface quality and the close tolerance. So these two will achieve because of this efficient flushing of the dielectric fluid. Okay, right. And what will happen if the flushing is not adequate? Okay, let us see. Inadequate flushing can result in arcing, a decreased electrode life and increased production time. Okay, so it will take much time to produce each part or product because of this inadequate flushing. Okay, right. Let us see the various methods of flushing. There are 4 methods of flushing. Okay, right. First one is normal flow. Second one is reverse flow. Third one is jet flushing. Fourth one is immersion flushing. Okay, so 4 methods of introducing dielectric fluid to the machining gap are considered at these 4: normal flow, reverse flow, jet flushing, immersion flushing. Okay, right. So this is the resource of these methods. Right. Now let us see the functions of the dielectric fluid. Okay, so the main function of dielectric fluid is the flushing. Okay, so here the importance or the significance of this today's topic is flushing. Okay, so the main functions of the dielectric fluid are flushing. Okay, first one, flush the eroded particles from the machining gap. Second one, provide insulation between the electrode and the workpiece. Third one, cool the section that was heated by the discharging effect. Okay, however, our focus is on flushing. Okay, flush the electrode particles from the machining gap. Okay, machining gap means the gap between the tool and the workpiece. Okay, tool and the workpiece. Okay, where the arc or spark will generate and the dielectric fluid medium will pass in between these two. Okay, right. So whenever the tool remove the workpiece material, nothing but debris, that it will have to flush. Okay, so the gap must be constantly maintained. In order to maintain that constant gap, frequently the debris must flush out. Okay, so here flush the eroded particles from the machining gap is the important point of discussion here. Okay, right. In order to have the constant gap between the tool and the workpiece, otherwise the inappropriate gap results in inappropriate sparking, so that the production delay will occur and some other consequences will be occur. Okay, right. Let me reiterate the methods of um, different flushing items. Here, normal flow is the first one. Okay, now we are going to discuss the normal flow. Okay, now look at this diagram. So in this figure 2, see the dielectric fluid medium is entering in this direction. Okay, so these are the electrodes and this one is the workpiece. Okay, so when the dielectric medium enters here, what will happen? It will away from the walls of this electrode and the workpiece in this direction. Okay, right. Now, in the majority of EDM applications, the dielectric fluid is introduced under pressure through one or more passages in the tool and the force is forced to flow through the gap between the tool and the workpiece. So that's what we have discussed already. Okay, right. In the EDM applications, the dielectric fluid is introduced. Already we have discussed that there must be dielectric fluid is to pass between the tool and the workpiece under high pressure. Okay, through one or more passages. Okay, one or more passages. Okay, in the tool and is forced to flow through the gap between the tool and the workpiece. Okay, this is tool and this is the workpiece. Okay, so here the tool is nothing but electrode. Okay, right. So this is about normal flow. We continue this one. Okay, flushing holes are generally placed in areas where the cuts are deepest. Okay, where the cuts are deepest. Okay, flushing holes are generally placed in areas where the cuts are deepest. Okay, normal flow is sometimes undesirable because it produces a tapered opening in the workpiece. So here you can look at this tapered open. Okay. Flushing holes are generally placed in areas where the cuts are deepest. Okay. But normal flow is sometimes undesirable because it produces a tapered opening in the workpiece as shown in this figure. See, this is the tapered opening. So because of this tapered opening, the dielectric fluid will flush away from this tapered way or tapered opening. Okay, right. Okay, right. Now let us discuss the second one, reverse flow. This method is particularly useful in machining deep cavity dies. Okay, this method is particularly useful in machining deep cavity dies where the taper produced using the normal flow mode cannot be reduced. Okay, here where the taper produced using the normal flow mode can be reduced. Okay, the gap is submerged in filtered dielectric, and instead of pressure being applied at the source, a vacuum is used. Okay, so here in reverse flow, what is happening? Instead of applying pressure, here the concept of vacuum. Okay, see in the normal flow, what is happening? See, look at here in the normal flow. So dielectric inlet will be in this direction. Okay, so that the dielectric fluid is come out from this tapered opening. Okay, this is about normal flow. But in reverse flow, what is happening? The gap is submerged in filtered dielectric, and instead of pressure being applied at the source, a vacuum is used. Okay, so here vacuum is used instead of pressure. Okay, so in the normal flow we have applied a pressured dielectric fluid, whereas here in reverse flow the vacuum is used. Okay, so this method is particularly useful in machining deep cavity dies where the taper produced using the normal flow mode can be reduced. Okay, right. Hope it is clear the difference between normal and reverse flow. Okay, so in normal flow, the inlet dielectric fluid direction into the workpiece. Okay, so here the pressure is applied. Okay, understanding? But in the reverse flow, the direction is opposite to the normal flow. Here, vacuum is used. Okay, so that's why it is called reverse flow. Okay, got it? So here it will enter in this direction and it will come out because of this vacuum. Okay, so in the normal flow, when the dielectric fluid medium is pressurized into the gap between the tool and the workpiece, the dielectric fluid will enter in this direction and it will come out through this tapered opening. Okay, so these are in these directions. Okay, when the dielectric fluid medium in the normal flow enter in this direction, it will come out in these directions. That means it will come out like this. But whereas in reverse flow, what is happening? Because of this vacuum, that means it will go up, reverse to the pressure. Okay, so it will enter in this direction, and again, however, it will come out to this workpiece and the tool wall, which is having a little taper, will come out in this direction because of this taper. Okay, right. Right. When, sorry, with clean fluid flowing between the workpiece and the tool, there is no side sparking and therefore no taper is produced as shown in the figure. Okay, so here there is no taper here. Okay, with clean fluid flowing between the workpiece and the tool, there is no side sparking and therefore no taper is produced as shown in this. Okay, in the reverse flow, there is no taper opening. Okay, right. Now, let us discuss jet flushing. In many instances, the desired machining can be achieved by using a spray or jet of fluid directed against the machining gap. Okay, so jet flushing, what is happening? The desired machining can be achieved by using a spray or jet of fluid directed against the machining gap. Okay, so this one, this is tool, this is workpiece, this is gap. Okay, so this is nothing but machining gap. Okay, the desired machining can be achieved by using a spray or jet of fluid directed against the machining gap. Right. The next point is the machining time is always longer with jet flushing than with the normal and reverse flow modes. Okay, when jet flushing is compared to the above two flow methods, normal flow and reverse flow, the jet flushing is somewhat different. Machining time. Okay, machining time is always longer with jet flushing than with normal and reverse flow modes. Okay, so that's why we have to limit this jet flushing where the time is important, but accuracy will be good in jet flushing. Okay, right, right. I want to reiterate these points. The desired machining can be achieved by using a spray or jet of fluid directed against the machining gap. The second point is machining time is always longer with jet flushing than with the normal flow and reverse flow. Okay, so in jet flushing, the time will be longer. Okay, so the machining time will be longer in jet flushing, but the thing is that accuracy point of view will be good. Okay, right. Now let us discuss the fourth one, immersion flushing. For many shallow cuts or perforations of thin sections, simple immersion of the discharge gap is sufficient. Okay, for many shallow cuts or perforations of thin sections, simple immersion of the discharge gap is sufficient. Okay, simple immersion of discharge gap is sufficient, so that's why it is immersion flushing. Okay, right. Cooling and machining debris removal can be enhanced during immersion cutting by providing relative motion between the tool and the workpiece. Okay. However, it is true always when we immerse anything, definitely the effect of cooling will be good. Okay. And the machining debris removal can be enhanced during the immersion cutting by providing relative motion between the tool and the workpiece. Okay, while we immerse completely, what will happen? It constantly flushes the debris. So that's why it will enhance the relative motion between the tool and the workpiece. Okay, so finally, the machining will be good in this immersion flushing. Right. In addition to that, vibration or cyclic interruption comprises periodic reciprocation of the tool relative to the workpiece to affect a pumping action of the dielectric fluid. Okay, so in addition to that, this cooling and machining debris removal can be enhancing. The next one is vibration or cyclic interruption comprises periodic reciprocation of the tool and relative to the workpiece to affect a pumping action of the dielectric fluid. Okay, right. So here the reciprocation of the tool relative to the workpiece and cyclic interruption. Okay, or nothing but vibration. Okay, to affect a pumping action of the dielectric fluid. Okay, right. Synchronized pulsed flushing is also available on some machines. Okay, so this is additional one, synchronized pulsed flushing. Okay, with this method, flushing occurs only during the non-machining time as the electrode is retracted slightly to enlarge the gap. Okay, so in synchronized pulsed flushing, what is happening? Flushing occurs only during the non-machining time. Okay, so during machining time, it will not affect. During non-machining time, the electrode is retracted slightly to enlarge the gap. Okay, right. Next, increased electrode life has been reported with this system. Innovative techniques such as ultrasonic vibrations coupled with mechanical pulse EDM, jet flushing with sweeping nodules and electrode pulsing are investigated by Java during 1990. Okay, so many authors or scientists have investigated the EDM with mechanical pulse. Totally, it is called MPEDM. Okay, mechanical pulse electrode discharge machine. Okay, in different directions. Right. For proper flushing conditions, the following was recommended by Metals Handbook, the year 1989. Okay, so we have to focus on these points for the proper flushing conditions. Okay, first one, flushing through the tool is more preferred than slide flushing. Okay, flushing through the tool is more preferred than slide flushing. Okay, so instead of slide flushing, we better prefer flushing through the tool. Second one, many small flushing holes are better than a few large ones. Okay, so instead of having large holes for flushing, we better provide small holes having the or considering the same area. Okay, right. Always small holes with large number will give better flushing. Okay, right. Many small holes are better than few large holes. Right. Third one, steady dielectric flow on the entire workpiece electrode interface is desirable. Okay, so it must be steady. Okay, steady dielectric flow on the entire workpiece electrode interface is desirable. Okay, so here always a steady flow of the dielectric flow on the entire workpiece electrode interface is desirable. Okay, so this is, let us say, entire workpiece surface. Here the flow of the dielectric fluid must be steady. Okay, right. Next, fourth point, dead spots created by pressure flushing from opposite sides of the workpiece should be avoided. Okay, so here the point is that we have to avoid these. Okay, what is that one? Dead spots created by pressure flushing from opposite sides of the workpiece should be avoided. Okay, understood? Dead spots created by pressure flushing from opposite sides of the workpiece should be avoided. It means same sides should be preferred for the flushing. Okay, right. Fifth one, a vent hole should be provided for any upwardly concave part of the tool electrode to prevent accumulation of explosive gases. Okay, is that one? A vent hole. Okay, vent hole nothing but a hole created on that to escape the gases from the area under the consideration. Okay, a vent hole should be provided for any upwardly concave part of the tool electrode to prevent accumulation of explosive gases. Okay, so that's what I told. Vent hole means hole provided to escape the gases. Okay, next sixth one. A flash box, okay, is useful if there is a hole in the cavity. Okay, a flush box is useful if there is a hole in the cavity. Okay, if we find a hole in this cavity, we better use a flush box. Okay, right. So these are the references associated to this presentation. So with this, I would like to conclude. So before conclude, just I summarize in short. Okay, right. These are the flushing methods. Okay, there are 4 flushing methods: normal flow, reverse flow, jet flushing, immersion flushing. Okay, right. The functions of the dielectric fluid, there are 3. Okay, but however, the most important one is the flushing. Okay, today's point of discussion is flushing. Right. There are 4 important flushing methods. First one is normal flow, reverse jet flushing, and immersion flushing. Okay, so in normal flow, what is happening? So because of the pressure of the dielectric fluid in this direction, okay, obviously the dielectric fluid will come out with these walls between the tool and the workpiece like this. Okay, exactly opposite to this direction of the dielectric inlet. Okay, that is about the normal flow. Okay, right. Now let us see the reverse flow. So here reverse flow means exactly reverse to this normal flow. Here vacuum is created so that the dielectric fluid enters in this direction and it will come out from the opposite wall of the tool and the workpiece. Okay, right. Now let us focus on this jet flushing. It is somewhat different to the above two normal flow and reverse flow. Okay, here the machining time is always longer with jet flushing than the normal and reverse flow. But however, jet flushing will give good results. Okay, though the machining time is longer. Okay, right. Immersion flushing. So during immersion, obviously, the cooling and the machining debris removal can be enhanced during the immersion cutting by providing relative motion between the tool and the workpiece. Okay, right. Next. So these are the proper flush or flushing conditions. The following was recommended by the Metals Handbook. Okay, however, we have discussed all these things in detail. Okay, so these are the references once again. Thank you very much. We'll meet in the next presentation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.